Greetings. This is the second part of vectors, where this type is more advanced than the previous one. So let's go for a recap, and this one is about collinear vectors. So earlier we mentioned in the previous video, collinear vectors, they are vectors that are parallel but they overlap each other, and you can see the definition at the top. Collinear vectors can overlap, and they can either be opposite direction or in the same direction. And you can see in the diagram at the bottom, you can see how collinearity looks like when it involves 3 points. You can see that because they are in the same direction, you can multiply them with a constant. And this is how you can tell if the vectors are collinear with each other, thus will lie on the same line. Now let's look into dot product. Okay, so you see here, this is a proof for the dot product of vectors. Okay, so dot product means it's a vector multiplication. When multiplied together, two vectors, they will produce a scalar without any new vector be produced. So by using the cosine rule and the modulus formula, so first you use the modulus formula, and then you change the magnitude of a minus b, and then you convert it to the cosine rule formula. You can see how the dot product for vectors is formed. And whatever you do, please make sure that both vectors are directed towards or away from the point. Then only the dot product can be used. And you can see that if the two vectors are parallel to each other, you get the maximum magnitude product. If they are parallel, if they are perpendicular, you get 0. And there's some properties such that if two same vectors are multiplied together, you get a magnitude squared of that said vector. And you can see that if vector I times vector I, you get i's magnitude I squared, which is 1. If not, it will become 0. And you can see that there are different properties of dot product, and I would like to highlight the first one, commutative property. And because it only produces a scalar, order does not matter here. And by this, you can safely get the dot product of the vector even if your order is reversed. Let's take a look at cross product. Now, cross product is different from the dot product because unlike dot product, cross product will produce a new vector along with its magnitude. And you can see new vector is produced upon multiplication, and the magnitude of the cross product is the area of parallelogram, as you can see. So you can see the proof as to how cross product can be formed. And just make sure that take note that order matters here because it is non-commutative, unlike dot product. And right hand rule is used so is to ensure consistency. Now if you look at the cross product, it somewhat looks similar to finding a 3 times 3 matrix determinant, except that it is in the form of a vector. However, I won't discuss matrices, as this is a separate topic from the vector topic. Now, nevertheless, you can see how the working is formed. And interestingly, the magnitude of the cross product is almost similar to that of the dot product, except that the trigonometric function used is sine. And you can see that if the cross product, two vectors are parallel, eventually you get 0. And if you take I times j, you get k. Reverse the order, you get negative k. And you can see all the properties are at the bottom. And of course, I mentioned the first one earlier, as this property is non-commutative. Now let's look at the vector equation. Now, vector equation is similar to that of linear equation, but it's in the vector format. And you can see how vector equation is formed on the left side of the diagram. You can see that the R is the final position, A is the initial position, lambda is parameter, and vector B is direction vector. Now we use the vector B more often, as is used to determine the line vector itself. And on the top right, this part is to determine whether two lines are parallel, intersect, or skew. So basically, if they are parallel, we can tell that vector B is a scalar multiple of vector D. If they are not parallel, either two lines intersect or skew. But to tell this apart, you can see that if the left hand side and the right hand side of the equation are equal and consistent, then you know the lines intersect. Otherwise, they are skew. Now, skew lines means that the two lines are on different planes, and you need to view this in 3D. Now, if you look at the bottom right, this is a foot of a vector. So first thing you need to do is to construct a rough equation of the shortest line from point to vector line, so to get that particular vector. Then use the dot product from number 1, and then you multiply it with the direction vector. And the third, you find the parameter. And after you find the parameter, you can find the magnitude of the shortest line of the vector. And this is how you do vector equation. I think that is all for me. I hope you like this video on vectors. Thank you.